Welcome back everybody to linuxacademy.com. My name is Terry, and in today's course we continue our preparation for the Linux Foundation Certified System Administrator exam. Specifically in this video we're going to be talking about swap partitions. Now, in short, swap partitions are designed as a special kind of partition for processes and the Linux system itself to use if it needs to page space before memory is available or when memory completely runs out. Now, keeping in mind that a swap space, although will prevent your system from crashing as long as it is not full when you run out of memory, it's hundreds to thousands of times slower than the system memory or RAM available in your system. So if you find yourself hitting swap space constantly, then it's probably time to upgrade the physical memory on a physical system or to create additional swap space on different partitions on your virtual file system, which is what we're going to do here. Remember, in Linux, everything is treated as a file system, or is treated as a file, whether it's a file system or device. So we can actually look at what's available for our swap partition, as far as we can do a df-h, but we can also do a cat on the proc swaps, which will tell us that dev sda2 as a partition is set up as an 8 gig swap partition with the highest priority of -1 or -1. However, you can have multiple swap partitions on your system. So we've got a device that we have added to our system that's an 8 gigabyte disk. So if we look at our fdisk utility -l, we'll see that we have SDB, which is an 8 gigabyte drive that has no partition information on it yet. So we'll use fdisk to do that. One of the things to keep in mind for a swap space from a logical perspective is that you want to have double the amount of memory up to 2 gigabytes in size, and then an additional 1 times the memory for anything over 2 gigs. So for example, on an 8 gigabyte system, you'll want to double the first 2 gigabytes for 4, and then the remaining 6 added on top of that. So you typically configure a minimum of 10 gigabytes. That way you can have a full kernel dump for all processes in memory, and then it still has enough space left over so that it can continue the functionality of the system if it has to dump the memory before a reboot. So it's important so that you get that kernel dump, which can be important to figure out why your system crashed. So in our case, we're going to be dealing with the SDB drive. So let's go ahead and do an fdisk on dev SDB. And if we do a P, there's nothing on it so far. So we're going to create a new partition. It's a primary partition, partition number 1. We're going to give it a particular type. After we give it the default size, we'll give it a particular type. Let's list those types. And since the beginning of Linux, the Linux file type for Linux swap has always been 82, so that's what we're going to indicate, is 82. Now if we do a print, we'll see that dev SDB1, 8 gigabytes in size, is set as a Linux swap partition. We'll write that to the disk, and then we'll exit. Now typically what we would do is we would format it here, but there's a special utility called mkswap. So all we're going to do is make swap on dev SDB1, and it will tell us it's setting up swap space on that partition with that particular UUID, and then we can turn on the swap space by executing a swap command. We can do swap on -v dev /dev SDB1. And it will tell us that a swap signature has been found, which is why we have to format it as that particular type with make swap, and we set it as the system file type as swap space, and then it gives us the default page sizes for setting that up. Now, if we do a cat on our proc swaps directory, we should now see 2 entries, which we do, and it says that it's using SDA1 or SDA2 rather as the default swap space and SDB1 as the secondary swap space. Now that's great, except for the fact that this particular swap space wouldn't start on reboot. So if we were to reboot the file system at this point, SDA2 would be all that would be listed in cat proc swaps. In order to get that so that it's persistently mounted on boot, we need to add an entry to the etc fs tab file. Now we can add it directly with dev sdd1, but let's see what it exists like now for the SDA2. So if we go to cat etc fs tabs, and we see that there's swap space for UUID 4F920670-4D3, etc. So as we've talked about in the past, from a mounting perspective, we want to mount by UUID so that if the drive letter changes because it's physically reordered in the file in the system, it's plugged into a different port or outlet, or we add another disk that changes the file system mount points from dev SDA and SDB, SDC to some other order, that we're not inadvertently trying to mount different file systems. So how do I get that information for the swap file that I've just created? Well, I can go to a directory that tells me what the UUIDs for all of my system devices are on the system. So again, because everything is treated as a file in Linux, we can go to the special devices directory. We can go and do an ls on dev disk and then by-uuid. And everything that is on the system since the last boot will show up here, but because this physical disk is SDB1, it shows up here at the top. So all we're going to have to do is make a copy of this. So we'll copy it here, clear our screen because it's a little confusing right now. We'll edit the etc fs tab directory so that we're going to add a line item here that largely matches what we have here for swap. So let's go over to here. We're going to add a line, UUID equals, and the reason we copied it is because we don't want to have to retype that whole thing in. We'll do swap, and defaults, and 0 and 0. Now we can turn off our swap by doing a swap off. So let's do a clear and do a swap off on dev SDD or SDB1. And now if we do a cat on proc swap, we see that it's been turned off. But if we want to test the mount that we've created, we can do a mount -a as long as we're root, df -h, and we see that the swap partition has been turned off. So now when we reboot the system, then everything that's in that fs tab command from a swap perspective will mount the secondary swap so that it happens after the first one, which is the SDA2 drive. That's all there is to creating a swap file. So we set the file type in fdisk. We use mkswap to format it. We use swap on or off to control it manually, and then we can add it by UUID to the system in the etc fs tab file for permanent reboot or persistent after reboot. That's all there is for making and using swap partitions. My name is Terry for Linux Academy.